Hello, everyone, and welcome to your video, which is going to talk about how we can use Heron's formula to find the height of a triangle. And so I'm going to give us a triangle here, and I'm going to tell us that the base of our triangle is 26 centimeters. But I'm not going to give you all of this information here. I'm just going to keep it simple. And I am going to draw a little picture showing us how we're going to calculate height. Remember, in order to calculate height, we have to drop a perpendicular, right? So here's our perpendicular line. And you're going to pretend like this is straight. And the 26 centimeters just is the black line. It does not include this little green, pretend bottom that I put on there. So anyway, I'm not giving you all the information of this triangle. I'm just giving you the base. And I'm telling you that if we had all of this information, we would figure out that the area of this triangle was 65 square centimeters. You can't figure it out because I didn't tell you everything that you needed to, but just pretend it's 65 square centimeters. So now we're going to use this information to determine what the height of our triangle is. So you know that the normal equation for the area of a triangle is 1/2 base times height. And so we're just going to fill in the information that we know. We know that 65 is our area. And we know that 1/2 can be rewritten as 0.5. And we know that our base is 26. And our h, or our height, is what we are looking for. That's our height right there. So let's solve this equation. So this is going to be 65 equals 13h. And if I divide both sides by 13, let me see, 65 divided by 13 is 5. So h equals 5. So my height is 5 centimeters. So I want you to see what we did. We used Heron's formula on a separate sheet of paper, and we came up with 65 centimeters squared. Then I just plunked that into the equation that I normally use to find the height of, or to find the area of a triangle, and I solved for height. Now, this probably seems pretty easy to you. I mean, maybe not completely easy, but you understand what we're doing here. The reason I started in the middle of the problem is because somehow, once you give students a triangle and you tell them this is 10, this is 15, this is 9. Once you give them this and they first have to do Heron's formula and then figure out the height, it's like they lose their minds. They're like, what? All these calculations? Yeah, you guys know how to do this. So let's do it. So step 1 is going to be to use Heron's formula. And then the second step is going to be to use regular area equation. So let's do it. So here, what is our perimeter? Well, our perimeter would be 10 plus 15 plus 9, which I have not had a Diet Coke yet today, so that is hard math for me. So my perimeter is 34 units. And so my semi-perimeter would be half of that, which is 17 units. So figuring out Heron's formula, A is going to equal 17, my semi-perimeter, and then 17 minus 15 is 2, and 17 minus 9 is 8, and 17 minus 10 is 7. I sure hope I'm doing that math right. Like I said, I am under-caffeinated. Okay, let's do this math. 17 times 2 times 8 times 7 is the square root of 1904. I don't suppose that has a perfect square. No, it doesn't. So now we're going to have to reduce it. Don't worry, it's going to be fine. Let me see, 1904 divided by 4. Oh, yeah, that works. So let's do the square root of 4 times the square root of 476. And then let's take 476 and see if I can break it down again, and I can. So now this is going to equal the square root of 4 times the square root of 4 times the square root of 119. Now, I am pretty sure that I cannot further break down 119, but I'm going to try. I'm going to do 119. I checked 4. I'll check 9. No. 119 divided by 36. No. 119 divided by 16. No. Yeah, I don't think so. So the square root of 4 is 2. The square root of 4 is 2. The square root of 119, we're just going to leave as the square root of 119. So we get 4 root 119. Now, I know you're thinking that is heinous, and you are not wrong. It is heinous, but it is also correct. So we're going to go with it. So I think what happens is that students do this kind of calculation. They see this wonky number. They start to doubt themselves, and they forget they know how to do the rest of it. Don't be like that. Let's use our regular equation. Our regular equation is 1/2 base times height. We know that our area is this ridiculously ugly number of 4 root 119. Our 1/2, please let me change that into something nice, which is a 0.5. Our base is 10. And our height is what we're trying to figure out. So this right here is what we're trying to figure out, the height. It's not 9, it's something. Okay, so let's figure this out. This is 4 root 119 equals 5h. Divide both sides by 5. I get even a worse number, which is 4 root 119 over 5. That is my exact answer. But just so that we can satisfy ourselves, let's figure out what this is. So I would do 4 times the square root of 119 equals, and then I divide that by 5, so it equals about 8.73. That's my about, 8.73. So that is a very good example of a very complicated problem. But you see that it's really not, there aren't really many steps. It's use Heron's formula and then plug that answer into the regular equation. That is how you go about figuring out the height of a triangle using Heron's formula. I hope that makes sense.